Every day, millions of us start our mornings with the simple physical force of a click. You enter a username, a password, and hit login. Within a second, the bank dashboard appears. It's a routine so frictionless that we rarely look at the mechanics behind the screen. But if we freeze time right at the moment that click occurs, a series of urgent questions appear. Where exactly is that password going? And how does the bank know that the person behind the screen is actually you? To find out, we have to slow down those 2 invisible seconds and track the data on its journey from your keyboard to the vault. That brief pause while the page loads is more than a delay. It is a high-speed digital border crossing designed to verify your identity while keeping the rest of the world out. The data packet containing your credentials leaves your browser, traveling to the bank's servers. The server's first defensive check: does the username exist? If the name is wrong, the server shatters the request instantly, failing the login before it even starts. If the username is valid, the server moves to verify the password, but it doesn't do this by looking at the word you typed. In fact, secure servers are built so they never actually store your password. Instead, they store a hash, a unique mathematical fingerprint. When you log in, the server runs your password through an algorithm, generating a new fingerprint. It compares this to the stored one. If the 2 strings match, the password is correct. This architecture ensures that even if a hacker manages to break into the bank's database, they only find a list of useless fingerprints. Without the original password to recreate the math, the data is essentially worthless. However, even a perfect mathematical fingerprint has a vulnerability. If a hacker tricks you into typing your password into a fake website, or if you reuse the same password across different accounts, the server's verification is no longer enough to guarantee it's you. To close this gap, the system looks for proof of what you have to supplement what you know. This is the core of multi-factor authentication, or MFA. This is why you're prompted to approve a phone notification, enter a text code, or provide a biometric scan like a thumbprint. This step confirms that the person attempting the login is in physical possession of a trusted, authorized device. It prevents a bot on the other side of the planet from accessing your account, even if they've stolen your password. By adding this layer, the system transforms a simple data match into a verified, geographically grounded confirmation of your identity. Once these checks are complete, the server grants you access. The login is successful, and you are finally inside your account dashboard. From here, you can click through your transaction history or move between different pages of the site without being asked to retype your password for every single action. This continuity is managed by a session, acting like a visitor badge at a high-security office. That digital token travels with every click, providing the server constant proof you've passed the checkpoints, allowing you to move freely. Zooming back out to the real world, this entire sequence, the data transit, the password hashing, the MFA in, and the session creation, is finished before your finger has even fully left the mouse. The simple login button is the trigger for one of the most sophisticated and critical security systems on the internet, protecting your digital life in less than 2 seconds. If you want to see how the technology we use every day actually works, consider subscribing to the channel. We'll be breaking down everything from cybersecurity to the inner workings of AI in future videos. Thanks for watching.